Picture the room at that moment. Photographs from that day show members of the Voyager's flight team gathered around a screen at JPL, and you can see it on their faces. The specific, disbelieving joy of people who had spent months not knowing if the machine they'd devoted careers to was already gone. Linda Spilker, Voyager's project scientist, called it simply a great day for Voyager 1. Bo, great day barely covers what had actually just happened. A team of engineers had reached across 24 billion kilometers, diagnosed a single failed component inside a computer with less memory than a text message thread, and rewritten that computer's own mind in pieces without ever touching it, without a single opportunity to physically intervene, using nothing but light-speed radio commands and 4.5 decades of accumulated understanding about a machine most of the modern engineering world has never even seen a schematic for. But this is where the story stops being a rescue and starts becoming something bigger, something with an expiration date built into it no fix can ever undo. Because the deeper truth underneath this entire crisis isn't really about one broken chip. It's about what that chip represents. Proof that Voyager 1 is dying, slowly, permanently, and there is nothing anyone can do to stop it. The spacecraft runs on radioisotope thermoelectric generators, essentially blocks of decaying plutonium converting heat into electricity, and that plutonium has been decaying since before the spacecraft even launched. Every single year, Voyager 1 has less power available than the year before. Not might have, does have. It is a mathematical certainty, written into the physics of radioactive decay, completely indifferent to how many brilliant engineers are fighting to keep the mission alive. And here's where you start to see the real shape of what's happening. Because NASA has been managing this decline for years in ways almost nobody outside the mission pays attention to. One by one, instruments have been deliberately switched off, not because they failed, but because keeping them running was no longer affordable in terms of power. Heaters have been shut down on instruments engineers assumed would freeze and stop working without them, only to discover, again and again, that instruments built in the 1970s kept functioning in conditions they were never rated to survive. A strange, quiet testament to just how conservatively over-engineered this 50-year-old machine actually was. Every shutdown is a trade, a calculated sacrifice of one capability to preserve power for something else, something the team judges more essential to understanding the region of space. Voyager 1, is now the only human instrument present to observe. Right now, as this plays, Voyager 1 is down to a fraction of the science instruments it once carried, and the team has already mapped out which ones matter most. The magnetometer and the plasma wave subsystem, the two instruments responsible for measuring the interstellar magnetic field and the density of electrons in the space between stars, have been prioritized above almost everything else, because that data is irreplaceable in a way few things in modern science are. There is no other machine anywhere in the reachable universe positioned to collect it. When those instruments finally lose power, that specific window into interstellar space, the actual physical texture of what lies beyond our solar system's edge, closes permanently, and nothing currently planned, nothing currently funded, nothing currently even on a drawing board will replace it for decades, possibly longer. Engineers at JPL believe they can keep at least one science instrument functioning into the early 2030s. Basic engineering telemetry, simple health, and status data with no science payload attached might be squeezed out until somewhere around 2036, the point at which the radioisotope generators are projected to finally drop below the minimum power threshold needed to run the transmitter at all. After that, the story doesn't end with an explosion or a dramatic final message. It ends with a signal that grows fainter and fainter across the deep quiet of space, until one day, it simply isn't there anymore, and the most distant human-made object in existence becomes a piece of drifting metal with nothing left to say to the world that built it. Voyager 1 will not stop moving. It will just stop being able to tell us anything about where it is. So think about what that April 2024 rescue actually was, in that light. It wasn't a permanent fix. There's no such thing as a permanent fix for a machine that is, by its very nature, running out a clock nobody can pause. What that team of engineers actually did was buy time. Precious, finite, irreplaceable time, purchased through raw technical skill and an almost obsessive institutional memory that has been quietly, deliberately preserved at JPL for exactly this kind of moment. Susie Dodd's team didn't save Voyager 1. Nobody can save Voyager 1. Not really, not in any permanent sense. What they did was extend the window during which humanity still has a living voice speaking to us from beyond the edge of the solar system. And in doing so, they gave scientists a few more years, maybe a decade, of direct, first-hand data from a region of the universe we will otherwise only ever be able to guess at from theoretical models and second-hand inference. This is what most coverage at the time missed entirely, buried under simpler headlines about NASA fixing an old spacecraft. The real story was never really about repairing damaged code. It was about the terrifying fragility of humanity's only physical presence in interstellar space, sitting on top of failing 1970s hardware, held together by a shrinking number of engineers who understand a technology the rest of the world has moved past, running against a power budget that ticks down every single day whether anyone intervenes or not. Voyager 1 isn't a spacecraft anymore. Not really, not in the ordinary sense. It's a countdown. It has been a countdown since the day it launched, and everything JPL has done for the last decade, including that extraordinary rescue in April 2024, has been an act of pushing that countdown backward by whatever margin engineering ingenuity can still buy. And there's a strange, quiet weight to what Voyager 1 is actually carrying while all of this plays out. Bolted to its side is the Golden Record, a phonograph disc engraved with sounds and images meant to represent life on Earth. Greetings recorded in dozens of languages, music spanning cultures and centuries, all of it sent outward on the off chance that something, someday, somewhere, might find it and understand that we were here. For nearly 50 years, that record has been traveling in total silence alongside a spacecraft that, until recently, could barely manage to describe its own internal condition back to the people who built it. There's something almost unbearably poignant in that. Humanity's most deliberate message to the unknown, riding alongside a machine whose ability to speak to us, its own creators, nearly failed completely, saved only by a small team refusing to let it go quiet just yet. There's another layer to this that almost never makes it into the coverage, and it changes how you should think about everything that happened in 2024. Voyager 1 is not alone out there. It has a twin, Voyager 2, launched just 16 days earlier in 1977 and sent on a different trajectory that took it past Uranus and Neptune before it. 2 eventually crossed into interstellar space in 2018. For most of this mission's history, the two spacecraft have functioned as a kind of insurance policy for each other, proof that whatever one probe experiences isn't necessarily unique to a single unlucky machine, but a shared condition of what it means to survive that long, that far, on that era of technology. When Voyager 1 went dark in November 2023, Voyager 2 kept operating normally, a quiet reminder that the failure wasn't systemic, wasn't some inevitable collapse hitting both spacecraft at once. It was one machine, one chip, one specific point of failure. But it was also a warning. If it could happen to one twin without notice, it could happen to the other, and there would be no third spacecraft waiting to take over if both voices ever went silent at the same time. NASA has been open about this calculus for years. The Voyager mission continues as long as at least one probe still functions. That sentence carries more weight than it first appears to. It means the entire interstellar science program built around this 50-year investment now rests on the survival of two aging spacecraft, either one of which could suffer its own version of the November 2023 crisis at any moment, with no guarantee the next fix will work. And consider what actually made the 2024 fix possible in the first place, because it wasn't luck, and it wasn't a stroke of unexpected genius arriving out of nowhere. It was decades of quiet, unglamorous preparation. Susie Dodd's team didn't improvise their understanding of a machine this old in the middle of a crisis. They had spent years, in some cases entire careers, maintaining documentation, preserving old programming languages, keeping alive an institutional fluency in 1970s aerospace computing that the rest of the technology world abandoned before most of today's engineers were even born. Think about what that means for the future. The number of people on Earth who can read, write, and troubleshoot Voyager 1's onboard code is not just small, it is aging. Every year, that circle of expertise narrows further and there is no pipeline replacing it, because there is no other spacecraft like this one anywhere in operation. When the last engineer who truly understands the flight data subsystem's original architecture eventually retires or is no longer available, the margin for another rescue like the one in April 2024 narrows with them, whether or not the hardware itself is still capable of being saved. This is the part of the story that should sit with you longest. Every additional year Voyager 1 survives isn't just a technical achievement. It's a race against two separate unstoppable clocks running at once. The physical decay of a plutonium power source that cannot be refueled, and the quiet erosion of the very human knowledge required to keep interpreting what that dying machine is still trying to tell us. NASA's own long-range planning already accounts for a future without Voyager 1's voice. Budget projections through the mission's 50th anniversary in 2027 show continued commitment, continued funding, continued effort, but nobody at JPL is under any illusion that this can go on indefinitely. The team isn't chasing immortality for the spacecraft. They are chasing years, sometimes single years. Sometimes, as with the 2024 rescue, they are simply fighting to make sure the machine survives long enough to see whichever fix comes next. What happens when the last transmission finally does arrive, whenever that turns out to be in 2030, 2036, or somehow, through more engineering brilliance nobody has invented yet, later than that? Voyager 1 won't stop. It will keep drifting, carrying that golden record outward, silently, forever, long after every person who worked on this mission, every engineer who fought through that 5-month crisis in 2023 and 2024, every person watching this right now is gone. It will keep moving through interstellar space for longer than human civilization has existed, a cold, dark, silent object still technically completing its mission. In the most literal sense possible, just without anyone left on either end still listening. So the real question was never whether Grok, or any AI, or any single dramatic revelation decoded some impossible hidden message from Voyager 1's final signal. The real question, the one that actually matters, is much harder to sit with. How much longer do we get to listen before the silence becomes permanent? How many more small, dying chips are waiting somewhere inside 46-year-old hardware, waiting to fail in ways nobody has anticipated yet? And when the day finally comes that Voyager 1 sends its true last signal, the one with no fix waiting on the other end, what will it feel like to realize that humanity's furthest voice has finally, quietly, after 50 years, stopped speaking? On November 14th, 2023, the most distant object ever built by human hands opened its mouth to speak. And for the first time in almost 50 years, nothing it said made sense. 15 billion miles from Earth, moving through a region of space no machine had ever entered before, Voyager 1 was still alive. Its transmitter was still humming. Its signal was still arriving on schedule, right on time, every single day, exactly as it had for nearly half a century. But when NASA's engineers opened that signal, they found something that looked less like data and more like static pretending to be language. Not silence, something worse than silence. A voice that kept talking but had forgotten how to say anything true. Here's what almost nobody outside a small room at the Jet Propulsion Laboratory understood at the time. This wasn't a glitch anyone could just reboot. There's no reboot button 15 billion miles from Earth. There's no technician who can drive out and swap a part. There is only a signal crawling through the void at the speed of light, taking 22.5 hours to reach the spacecraft, and another 22.5 hours for any reply to crawl all the way back. Every question NASA asked Voyager 1 came with an answer nearly 2 days later. Every mistake would cost 2 days to discover, and somewhere on that 50-year-old machine, something had broken in a way nobody could see, on a device nobody could touch, in a place nobody could reach. And what most people don't realize is that Voyager 1 was never supposed to still be out there. It launched in 1977, riding a wave of Cold War ambition and old world engineering, built to survive a 4-year tour of Jupiter and Saturn. That was the mission. 4 years. Instead, it kept going. It used Jupiter's gravity like a slingshot, then Saturn's, hurling itself faster and faster out of the solar system entirely. And in August 2012, it crossed a boundary no human-made object had ever crossed before. It left the heliosphere, the bubble of charged particles blown outward by our sun, and entered interstellar space. Real interstellar space. The region between stars. It became the only functioning machine humanity has ever had operating in that environment. A 40-year-old spacecraft running instructions written on punch card-era logic, reporting back from a place where the laws of normal spacecraft engineering simply stopped applying, because nobody had ever engineered anything to survive there in the first place. And that's the part that should stop you. Voyager 1 isn't failing because it's old and worn out in the way an old car's worn out. It's failing because it has been sitting in an environment of cosmic radiation, extreme cold, and total isolation for over 4.5 decades, running on hardware from an era when a powerful computer filled an entire room and processed a fraction of what sits in your pocket right now. Its flight data subsystem, the onboard computer responsible for gathering readings from its instruments and packaging them into a transmittable signal, holds a total of 68 kilobytes of memory. 68 kilobytes. It processes about 8,000 instructions every second. Your phone processes roughly 100 billion. Think about what that means. The most important scientific outpost humanity has ever placed outside our solar system runs on less computing power than a musical greeting card. And in November 2023, some tiny piece of that fragile, irreplaceable 46-year-old machinery began to die. For 5 straight months, that's all anyone had. A steady signal, arriving like clockwork, carrying nothing but noise. Voyager 1 hadn't gone silent, and that was almost the cruelest part. Total silence would have at least been a clear diagnosis, something final and simple. Instead, the spacecraft kept talking. It was clearly receiving commands from Earth. It was clearly still operating, still pointed correctly, still functioning in every way engineers could verify remotely. But everything it tried to say came out scrambled. A garbled stream of ones and zeros that refused to resolve into anything readable. Imagine calling someone you love, hearing them pick up, hearing them breathing on the other end of the line, and hearing them try to speak to you in a language that no longer exists. That was Voyager 1's condition for 5 months, alive, present, unreadable. This is where the story stops being about a machine and starts being about the people underneath it. Because what happened next is one of the most extraordinary acts of technical detective work in the history of spaceflight, and almost nobody talks about it. Susie Dodd, Voyager's project manager since 2010, led a small specialized team at JPL, a team that had spent years quietly maintaining the institutional memory required to operate a spacecraft that predates almost every engineer alive today. Read that again. The knowledge required to fix Voyager 1 doesn't live in a manual. It lives in the heads of a handful of people who have spent careers learning a computer architecture that the rest of the world abandoned generations ago. And in November 2023, that knowledge became the only thing standing between humanity and the loss of its furthest outpost in the universe. The team began where every good investigation begins. Not with a fix, but with a question. What precisely had gone wrong? For months, they couldn't even get that far because the scrambled signal itself was the obstacle. They were trying to diagnose a patient who couldn't speak. But in March 2024, they tried something. They sent what engineers inside the mission started calling a poke, a deliberately crafted command designed to prompt the flight data subsystem into doing something specific, reading out the entirety of its own memory and transmitting it back to Earth, garbled or not. It was a long shot. It was also, at that point, one of the only moves left on the board. Then came the wait. 22 and a half hours out, 22 and a half hours back, nearly 2 full days for the universe to answer a single question. And on March 3rd, something changed. A Deep Space Network engineer noticed that one section of the returning signal looked different from the rest of the garbled noise Voyager had been sending for months. It wasn't in the format the team expected, but it wasn't nothing either. This is where it gets worse before it gets better, because now the team had a new signal and no idea yet what it meant. They had to decode it from scratch, working backward through a structure nobody had anticipated, essentially reverse engineering a message from a machine that could no longer explain itself in the language its builders had designed. It took 4 more days. And what they eventually found inside that anomalous section of signal was staggering in its scope. A complete readout of the flight data subsystem's entire memory. Every instruction, every stored value. The whole internal architecture of Voyager 1's mind laid bare across a distance of 24 billion kilometers. By March 10th, 2024, the team had their answer, and it was almost anticlimactic in its simplicity, which somehow made it worse. A single chip inside the flight data subsystem had failed. Just one chip out of the entire spacecraft, out of 46 years of continuous operation through radiation belts, planetary flybys, and the crushing isolation of interstellar space. That one chip happened to store a portion of the FDS memory, and that portion happened to include a piece of the computer's own operating code, the actual instructions the machine needed in order to function correctly. When the chip died, it didn't just lose data, it lost part of its own ability to think. About 3% of the flight data subsystem's memory had been corrupted. 3% doesn't sound like much. 3% was enough to render the entire spacecraft's science and engineering output completely unusable for 5 months. Nobody knows with certainty what killed that chip. NASA's working theory points to either a cosmic ray strike, a single high-energy particle from deep space slamming into 46-year-old silicon and scrambling it at the atomic level, or simple patient wear, the kind of failure that was always going to happen eventually to hardware never designed to run this long in an environment this hostile. Either way, the conclusion was the same, and it was brutal in its finality. The chip could not be repaired. It could not be replaced. There was no spare parts drawer at the edge of the solar system. Whatever the team was going to do, they had to do it without fixing the actual damage, because the actual damage was permanent, sealed inside a component floating 15 billion miles from the nearest screwdriver. So the engineers did something that sounds almost too strange to be real, and yet is completely, verifiably true. They decided to move the code, not repair it, move it. The corrupted section of software still existed in the sense that the team knew what it was supposed to contain, based on decades of documentation and their own hard-won understanding of the spacecraft's architecture. What they needed to do was find a new home for it somewhere else inside the flight data subsystem's extremely limited memory, somewhere the dead chip couldn't touch it. But here's where the problem escalated again, because the code was too large to fit into any single available block of memory elsewhere on the system. There simply wasn't one empty space big enough, so they broke it apart. They split the corrupted code into smaller fragments, small enough to slot into scattered, unused corners of memory across the flight data subsystem, like fitting broken pieces of a shattered object into whatever gaps happened to be available, then rewriting the connective logic so that all those separated fragments, sitting in different physical locations inside the computer, would still function together as a single coherent program. This is digital surgery performed at a distance of 24 billion kilometers, on a patient that cannot be sedated, cannot be paused, and will not survive a mistake. Every command still had to travel that same 22-and-a-half-hour journey outward, and every confirmation still had to crawl the same distance back. There was no room for trial and error in any conventional sense. Each attempt was a 2-day roll of the dice. Understand what was actually being risked here. This isn't a company patching a bug in an app overnight while users sleep. This is one of the most consequential scientific instruments ever built, a spacecraft that cannot be replaced, cannot be relaunched, cannot be recovered if the fix goes wrong. If that relocated code failed to execute correctly, if even a single instruction landed in the wrong sequence, Voyager 1 could have been lost entirely, not through some dramatic explosion or catastrophic failure, but through total permanent silence, a signal that simply stops, forever, with no way to ever know exactly why. The team wasn't just fixing a computer. They were performing the most delicate procedure imaginable on the only witness humanity has ever had to what lies between the stars, knowing that one wrong move meant losing that witness for good. On April 18, 2024, the team sent the first relocated block of code, a piece of software responsible for reporting the spacecraft's own status, chosen deliberately as a test case, something small enough to risk, important enough to prove the theory was working. Then they waited, 22 and a half hours outbound, and then the second half of that agonizing math, 22 and a half hours for any response to make its way back across a gulf of empty space wider than most of us will ever be able to comprehend. On April 20th, 2024, the answer arrived. Clear, readable, correct. For the first time in 5 months, Voyager 1 had said something that made sense.